I can't even get headphones to work with CC. So I think you guys could hear me out there. Somebody already rang our chimes. So welcome to this week's class, which is February 27th, 2013. Posted to the board asking if lecture is on media tonight. The HTML5 class can sit in, but this is not a lecture that applies to the HTML5 class. So I don't know if Jeremy's on here, or if somebody, let me log into our class page and I could reply to him, I guess, but he's not on here anyway, so I can reply to him when I get home. But this class is really for the CS53 11B Advanced Dreamweaver class. And what we're going to talk about today is databases. So the MySQL database in particular, but we're going to talk about databases in the context of websites. So we don't need this anymore. But if you think about what this class sort of has evolved into, as I said in the first couple of weeks, it's really about building database-driven websites, right? And so far, we've built some websites that are dynamic. They have some intelligence to them. They can figure out how old you are if you give them a birth date, or they could send an email if you fill out a form. But the next step is to then interact with a database so that there's data sitting in a database, there's information on a website, and we can sort of merge them and match them up and create better databases. So, sounds like there's a question. Maybe not. Anna is, I'm not sure what that means. Did you get my email about homework? Yes, I did. So I will reply to your email, Anna. There was a bug in the homework submission thing that I fixed, but 3 people entered homework without the ability to enter a comment. So you're one of them. So I'll talk to you about that offline by email. One of them I fixed. So, but that brings up a good point. So before we get started about the topic, let's just kind of circle back into the class and see where we are. So www.santarosa.edu. So I'm going to go to our website for this class. I apologize for not having it set up. There's a class, like I said, before us for a couple of weeks more. So it takes us a few minutes to get things going here. How do I get back on track? Where to start? The best thing is to start at the top of the class and work your way down, I guess. Let me get to the class page and maybe that will make more sense. Come on. All right. I don't need that. I don't need that. I don't need that. I don't need that. Need to log into our site. So okay, so we're actually on February 27th. So when you log in, you go to the next section, and this is what we're going to talk about today. To answer Cal's question, how do you catch up? You know, I wouldn't go back. So first of all, let's talk about the exercise feature that we added to the website, right? So there are a few people who have started to submit their exercises. Right? So to submit your exercise, you click that button. It knows who you are. I'm logged in. You'd be logged in. You can't see this without being logged in, right? So All you have to do is say, this is the specific page on my gallery where my exercise can be found, and put a little comment. I had no idea what I was doing. Help me make this work. Or, I did so much, Jay, you don't know what you're doing. I went way beyond what you did. Check this out, or whatever it is, you know. Then, once you do that, it'll just be your first name and your comment. And then when you click here, you will give people a link to whatever it is that homework assignment is. Right? Pretty straightforward. This stuff doesn't really work yet. It's just kind of an idea I have for somebody saying, I don't like what you did, or I like what you did, but I haven't hooked it up yet. So it's sort of a social way within the class of doing either a peer review or something like that. So that's something that might come down the road. Right now, you can do all the thumbs up and thumbs down you want, but we're not yet recording it at this point. Okay, does that make sense? I'll let you know when we start doing it. You're logged in? Well, you have to go a week before. This won't show up for exercise notes unless anybody submitted them. So if you go up, I'm looking at February 20th right now. It doesn't show up on your screen. Doesn't have that, huh? Well, he's on Windows, and I'm on Windows. Oh, no, it shows up on my Mac. Yeah, interesting. Yeah, I don't know why it's not showing up. You're using Chrome? Yeah, interesting. I'll have to look at it. Maybe it's another problem. So let's talk about the exercises. Like I said, you're not really going to get a letter grade for submitting the exercises. You're not required to submit them if you don't want to have me know that you did them. Or let me put it this way, if you don't want feedback, either from me or possibly other people in the class, you don't have to submit them. But if you don't want feedback, obviously you have to share it. Okay? So that's one thing that's new on the class page. Another thing that's new on the class page are these wiki things, right? Links to these 2 wiki pages. So I created these. Does it work? I created a wiki for our class, actually for both classes. So it's a shared web space that we can use to collaborate on knowledge as we learn it throughout the class, right? So I sent you all logins, right? Did you get anything by email? Yeah. If you check your email, and it went to the email that you used. That's a good point. So, yeah, so you bring up a good point, which is, okay, now I have to log into this. I have to log into the website. It's a different login for this wiki space. You're right, it's a payment. That is a payment. It's something I prefer not to do. Yeah. So what I'd like to do is bake a wiki into our class page. It's a little bit more programming and resources, and I have to do that by next semester. But for now, a lot of instructors use this wiki space thing. Has anyone used it before? Yeah. So is anyone interested in this? What does it do? So let's log in. I'm just going to log in as myself. Once you log in, you should be logged in. So, you don't have to remember all these passwords. I might be speaking early. So I'm an administrator, so I see something a little different first. But this is our page for our classes, our welcome page. And whether you're in the HTML5 class that I teach, or this class, you get the same thing. It's one page. We're sharing it. And hopefully, going forward next semester, I'll use the same resource. So the knowledge we add this semester will be added on to snowball next semester. But anyway, That's what this says. Essentially, there's 2 pages. A glossary, which right now has 2 terms, of which I created those, and nobody's edited them. And in addition, there's a web development links page, which is just a list of links, which a few people have already added to. So what might be nice is if during this class, people are always saying, can you stop the class and put the link into the Illuminate? Well, having those links in Illuminate, you have to find them and all that. So if somebody just wants to keep this page open during the class and edit it and add to it, that would be a great thing to do. You get an automatic A, and no, I'm joking, but you would, but it would be a cool thing to do. It would be in the spirit of the 21st century, in that we are learning collaboratively, we are sharing our knowledge, we are getting better knowledge by sharing it. We're kind of taking class notes for everybody. Does that make sense? So that's what a wiki is. This wasn't possible 10, 15 years ago. And it's one of the things that show, like our class page, that what makes a site, a website, sort of a web application these days, is a few things that you don't really think about. One of them is personalization, and another is socialization, right? So personalization. Our website has personalization. It knows who you are. When you submit an assignment, it knows who you are, right? If you've already submitted that assignment, hopefully it'll say you already submitted this, right? When you go to thumbs up or thumbs down somebody else's, it knows who you are and knows who submitted that, right? The other thing is social. So because it knows who you are, it could allow you to interact with other people indirectly through the site. You could thumbs up or thumbs down somebody else's work, right? So that, like I said, not all of this is developed on our site yet, but this is part of what makes websites so great these days. And part of what we're learning in these classes is how to build sites that do this, that enable these things. So like I said, we're building a social network. We are literally building a class social network. This is what Facebook has, thumbs up, thumbs down, comment about a post. So let's go back to our traditional social network and see what the question is on here. So do we have access to this site while we are students? And good question. So the wiki, you have an account now on that wiki, and you could use it for whatever you want. You could create your own wikis. You have an account on Wikispace, and that account gives you access to my wiki, but you could use it for other things, and there might be other classes that use Wikispaces. So there were 3 or 4 people in this class that already had an account because they might have taken another class and they might have used it before. So instead of creating an account for them, I just gave them an invite to our wiki. So I don't know if that answers that question. I accidentally submitted homework twice because it wasn't clear it would have been sent. Yeah, so I've made it a little clearer. Like I said, there was a bug, and I know you submitted things a few times, and we'll work on that when I send you an email after the class. So back to the class page. So 2 new things. These wikis are here if you want to use them. If you don't want to use them, I'm not making them a requirement. You don't have to define 10 things in the wiki as a homework assignment. Although maybe that would be a good idea, actually. That would be a good midterm. Write an essay on the wiki. Choose one of these terms and write an essay on that. That is good. I like that. All right. So let me think about that one. But anyway, it's just a class resource that I've made available, and we'll see how it goes. Let me know how it goes. Some of this looks like it might need some editing. So anyway, back to the class page. So this class, where is our class page? There we go. So this class this week is an introduction to databases. Okay, So, and particularly want to focus on using a database in the context of a website. Okay. Towards next week, we'll get a little bit more into what the website part of that. Today, we might just get through what is a database, create a database, start working with a database. So, can I ask a question that keeps coming to mind? Will Google index this wiki? That's a good question. I'll have to answer that. I'll have to look into it. I don't know, there might be a way we could turn it on or off. The net is you can't get to it unless you have an account. So I doubt if they are indexing it because they can't get to those pages. So yeah, to answer your question now that I think about it, our pages are password protected. That means our class page is password protected, those wiki pages are password protected, but don't slander anybody or anything like that, even though they're just within the class. Be respectful.
There's no metadata on those pages.
Yeah, the wiki is not, it's not going to be, well, Google will index something without metadata, but it's not going to index that because they can't get to it. It doesn't have the password. Only you have the password, right? The password I sent you in email, right? So, which brings to mind part of this topic. The information is in a database. It's not on a web page. In order for Google to index it, it's got to be presented on a web page that can be indexed. And it won't do that unless you have the password to create a web page dynamically that Google can index, right? The same thing with our website, right? The content is in the database. If Google can recreate this page to index it, they would, right? But they can't because we password protected it, right? I have other pages on santarosa.edu that are password protected that do get indexed on Google, right? If you type in like, let's see, web JavaScript class Santa Rosa JC. Maybe not. Yeah, so, well, this is on my site, which I used for a while in the class, but I think I used to see, here we go. So this is our class, the parent of our class page, and you can see that it's indexed on Google. But our page is not because it's behind a wall. It's behind a password protected wall that Google can index. So, databases. Question?
Are you doing where you're setting up a database on the hosting provider? Any hosting provider?
The question was, am I going to go through setting up a database on any hosting provider? I wasn't going to do that. I was going to go through setting it up on the student.santarosa.edu server first. What hosting service are you using? Or yeah, so typically you would use there's a thing called the control panel, and usually there's a database section in there, and you could create a database. It's usually pretty menu driven, but I can't go through it for every web host because it might be different for each one. With Sonic, if you use Sonic.net, which is a local, Santa Rosa or Sebastopol company, a lot of people use, they don't use control panel. They have a special member tools interface. But again, setting up a database there is free and is very straightforward. It's just a couple of menu choices.
I've noticed a lot of the hosting providers I use, if they run free ones, they all have control panel.
Right.
Menu for going behind the scenes and doing things. Now, is that becoming a standard for all hosting providers to use control panel?
Yeah, so the question is control panel becoming a standard? Like I said, Sonic doesn't use it. But most of the other hosting companies that I've used recently do use control panel, which I don't know if you know what that is, but it's a pretty consistent interface for systems administration for a web designer. You know what I mean? It makes it pretty, you don't have to be a Unix administrator to do things like work with a database. Now, there are special circumstances. Like I said, Sonic doesn't provide control panel. I'm teaching towards the JC server because we provide that for free, and that doesn't have control panel either. So we're going to have to use the command line to get in there and, believe it or not, and set up our SQL environment. So hopefully I'll be able to do that in a minute to show you how to do that. All of you should have or can get a free account on the JC server, the student server, and that does include free access to a MySQL database account. All right? Doesn't give you as much flexibility as you would get if you used it on a third-party hosting service. And we'll talk about what I mean by that flexibility, but it is a free account, and it's available through the JC. They only offer you one account. Yeah, they actually offer you a couple of logins, but they're all to the same account. Yeah. On the center as a JC, you could create new schemas, but you can't. I think you could create new schemas. We'll try it today. Okay? I think you can create new schemas, but it is limited. You can't install it. You can't create a new database, but I think you can create a new schema, which is very similar to a database, I believe. So, lots of questions. Questions on here. Answered that one. So, how do I get rid of this? So, first of all, what is a database? At a very general level, what is? Correct. Well, a place to store information. So, so that first question raises sort of a terminology thing. I might as well keep this open since I'm asking questions. Tabular information. Both of those are correct. And both of those are not incorrect. But one thing to bear in mind is a database is a collection of information, or actually a collection of data, right? And a database management system is a software tool for creating and managing databases. And a lot of times we kind of use those terms interchangeably. Does that make sense? So MySQL is a database management system, and the information that you are going to put in the database you create using MySQL is going to be a database. Right? So that's one thing. So the database is the data. But a lot of people call MySQL a database. It's really a database management system. It's software that you use to manage and create databases. So that's one fine definition. Okay. Your definition was a collection of data? A collection of information. So, yeah, it's really more a collection of data in a way. Information, data is plural for datum, which is Greek for fact, right? And a data is a bit. It's a bit of information, right? An analogy. So let's see, what Brett Pill did in the third inning of today's spring training game is a datum. You know, he did something, he either struck out, or he got to first, or he popped out, he did something. But that's not really much information. It doesn't tell you who won the game. It doesn't tell you where they played. It doesn't, So to kind of clarify your question, a database is a collection of data, and if you built it right, you should be able to get information from it. You should be able to glean information from it. But data by itself might not give you a lot of information because it's just bits. It's just pieces of information, right? So, but yes, you are not incorrect. And Anna, tabular information. So there are different ways that database management systems organize data to make it informative. And tables are a very typical way of doing so. And a database that uses tables, tabular, a tabular motif for storing information is typically called a relational database management system. Okay? And MySQL, the tool that we're going to be using in this class, is a relational database management system. It stores all the data that we provided into tables. Okay? So that is correct. Organizing data information, that is correct. Spreadsheets, we're going to get to that, Tony. Storage area for interactive data, that is also not incorrect, Cal. It's a storage area for interactive data.
Now are databases and MySQL all done with PHP code?
The question is are databases and MySQL in particular all done in PHP code? No. So, but I'll answer that question as we go along. You could use PHP. PHP has an extension for interacting with a MySQL database. But I'll answer your question maybe now. Databases have their own language for interacting with them. And PHP and JavaScript and HTML and CSS are pretty useless when it comes to databases, unfortunately. So what we're going to learn, what we're going to start learning today is a new language. Language number, what, 5 in this class? A whole new computing language just to work with a database. Because a relational database management system, one of its definitions is that the data is stored in tables. Another definition is that you can only interact with it with the computing language known as SQL, or some people call it SQL, structured query language. So that's the language we're going to learn today. And PHP has a library, a set of functions that enable you to send SQL statements to the database, which results in a result set, either data coming back or data that has been changed, an acknowledgement that it's changed data or whatever. So we're going to be using PHP to interact with the database in this class, but almost all programming languages have some way of interacting with databases. Python, Ruby on Rails, they're all very database-centric, server-based languages. ASP, which is Microsoft's sort of programming language for the server, a lot of it is based around interacting with databases. So PHP is just one of many, but it is probably at this point the most popular. It's used by WordPress, which a lot of people use to build websites. It's used by Facebook. PHP, like we said, is a pretty common way of building web database applications.
So if PHP already is capable of talking to a database, why is there an extension defined specifically for MySQL?
The question is if PHP can already talk. So yeah, that's semantics. So PHP can talk to a database because of this extension that can interact with MySQL. And if you're using, MySQL is not the only relational database out there. So there are many products that are relational databases. MySQL is one of them. And PHP has an extension, a set of functions for talking to MySQL. It also has a set of functions for talking to the other relational databases. Microsoft has its own relational database that it sells on Windows. And does anyone know what that's called? It's called SQL Server, SQL Server. And it comes with like the Windows Server Edition. Or they probably charge for it now, SQL Server, I don't know. Has anyone heard of Oracle? So Oracle is a they were the first company to develop a commercial relational database management system. So, and they also now own MySQL. So they have a free open source product, and they have a very expensive commercial product for large companies. And they support them both at this point. So there are other relational database management. IBM has one. 10 years ago, a commercial relational database management system was a very expensive product. The richest person in California is Larry Ellison, who started Oracle, right? It's not richer than Bill Gates, but he's catching up. So there was a big market, and they were very expensive, $20,000, $30,000 per server for small servers, like what we're doing here at the JC for a class like this. For PG&E to run an Oracle database for their billing system, it was probably $20 million a year, right, or more, plus programming time and all that, just in the license fees. Because these are massive things. Think of the databases behind, like Facebook. So if Facebook and companies like that they created their own MySQL. They contributed to that because they didn't want to pay Oracle all that money for that licensing. And that's where open source kind of started in many ways, at the operating system and then at the database level. So anyway, there are different types of databases. There are different languages. What we're using in this class is just one example, but it's the most common, one of the most common examples. It's also a free example. It's also not only a free example here at the JC, but as we've said, almost every hosting service that you can get for $5 or $6 a month, or sometimes even for free, will give you PHP and MySQL for free. Just setting up takes 2 seconds. So and it's very, very powerful. Like I've said, you could I don't know if you could build PG&E's billing system, but you could kind of start building Facebook like we've done in our class here, or something like it, a database managed website. So so databases. So everything is stored in tables. So the class before this, the reason we're always about 5 minutes late these days, is a Microsoft Excel class. And a few people before the class in this class mentioned, this is a real programming class. That is not. Well, Microsoft Excel has a whole bunch of programming capability. Microsoft Excel is what? It's a table, right? So we're talking about a database that we're going to use that stores information in tables anyway, right? What are some of the differences between using something like Microsoft Excel, which is, it's not really a database, it's a spreadsheet software, and a relational database? There were essentially 2 main differences. You can't relate, it's very difficult, if not impossible, and not designed to relate data from one table to another. So you wind up with a lot of redundant data, right? Because the elegant beauty of a relational database is if you design it correctly, you should have no redundant data. You don't have to put Brett Pill every time he comes up to bat. You create another table with all your batters, and you assign him a number. Anytime he comes up to bat, you reference the batters table in the at-bats table. And you don't need to have one table that has Brett Pill 100 times. You know what I mean? If you misspell his name once, your whole database is messed up. You know what I mean? Because you'll never get the right summary data. So consistency in organization comes through being able to relate a column in one table to a column in another table for what's called referential integrity. So that's one major difference. What would be another difference? Why couldn't you run PG&E's billing system off of Microsoft Excel? Right. So one thing is you could manage it. So I think what you're talking about is control or manage it. So you can get a professional IT guy to manage it. And that's something that IT people say a lot. So that is somewhat of a disadvantage. In other words, if it's on Excel, it's on somebody's computer somewhere. And if it's running the whole whatever website or statistics for the major leagues, and it gets stolen from an airport or something, it's gone. So having it in a data center where it's backed up and all that is an advantage. That's correct. But the real advantage is to take a step further, which is Excel is not really designed for multi-user capability. It's meant for one person, typically, to update those cells at a time. Does that make sense? It's not, if a whole office is using the same spreadsheet at once, they will overwrite each other's data pretty quickly, right? Whereas a relational database is designed from the start for multi-user access. You can't really go in and change a cell. You could just tell it to change a cell by using this SQL language. And the SQL language ensures what's called transactional integrity. In other words, you cannot overwrite somebody else's changes without your changes coming in first. Serialization. So there's a whole class of MySQL, and some of these things or features or concepts we're talking about might be more appropriate in that class. But I think it is important to talk a little bit about this. So we store information in tables, but we can refer to them. And that's going to give us a lot of power. The other thing is we can use a database and share it in a multi-user way. So, and we're doing that with our website, if you think about it. Different people could submit different exercises, and they're not sharing a spreadsheet that has to be saved. If you think about it, a spreadsheet is a file. So if you submit your homework, you're opening a file and then saving it. If two people do that at once, things are going to break. In a database, you're not really opening a file, you're passing a command, and that command is just being executed on one row of the database, without it having to open a file, lock that file, and then change that file, unlock it, and write it back to the disk. So databases have row-level integrity, which enables very massive numbers of users to interact with the same data set without overriding each other. And we see this again and again. There's one database behind Amazon, right? Think about that. There's one database behind Facebook. Why would that make sense? Because the whole world is there. You don't want the same person, to be in two different databases. So you need one logical view of one database. If you're logged in here and you get on a plane, you go to Singapore, you log in, you want to be the same person, right? So there's one database. It just kind of makes sense. Very difficult to do that in a spreadsheet. You can't get all these people to update rows in a spreadsheet because it's a file. Databases are not based on files. So there's really two big advantages, and those advantages turn out to be big advantages. To a company like Amazon that can run a whole business from one product, especially a free product. You know what I mean? A MySQL database.
Everything is sectioned out of tables.
What these large, massive databases have to do, their challenge is not how big does the table get. They kind of have to spread the tables out over many, many disks and make them redundant. So the way these large databases are managed are probably beyond this class, but the point is sort of at a logical level, they present it all as one database. It always looks like it's one thing. You have one record in there. If you make a post, it's in there once, not twice. Every time you log in, you see the same consistent view. And the same thing with Amazon. If you order something and you log out and you log into another computer, you can see that order. Right? It's one database. That's a big advantage. One consistent view is a very important thing. Could you try to run a company like Amazon where they have many databases? You'd have to, put that all together to do your work. How many orders do we have to ship out of this warehouse today? Well, I don't know. First, we got to look in that database. We got to look in the books database. Then we got to look in the perfumes database. Then we got to look in the households database. You can't run a business like that. I started working at Oracle, the company that built these databases, in 1991, and we had databases in each country because we sold databases. It was great. Just set one up, and so the HR department in every country would set up a database to track their employees because every country has a different HR thing. In France, they get 20 weeks of vacation, and In Germany, you know, they know when you're in your office or not. You know, every country has different rules for employment. So all these HR managers create all these databases, and I worked at the headquarters. And one day Larry Ellison said, how come I can never figure out how many employees we have in this company? So, you know, we said, you know, I don't know. You know, you just look at HR. He goes, well, you can't because every department has their own HR thing. So that's an example of what you don't want, right? That's not the right way to build a database. It might give you data, but it doesn't give you information. Here's the guy that runs this large company that, without databases, he couldn't figure out how many employees were in the company. You know, this guy from Wall Street asked him, how many employees do you have right now? I couldn't figure it out. So databases are great, but they only manage data. When you design them correctly, they can give you invaluable information. If you don't design them correctly, they can be a disaster. So database design is a very sort of important concept and an important skill, but beyond this class, really. And database design is essentially how you create the tables and relate them to each other so your database makes some sense. The data within it kind of makes some sense. So designing a database is really modeling the real world. Taking a step back from the real world and looking at the nouns and verbs that we are to make us. So let me give you an example of what. Let's do this. So I am going to see if we have the MySQL Workbench software in here. Yep. So this is software that you're going to install on your computers. You don't have it yet. We'll do that in a minute. But right now I'm just going to demonstrate it. You might have it on your computer. I put a link to it on our website, so if you want to start downloading it, download MySQL Workbench is right here. You're not going to be able to connect. You might not even have a JC. You might not have a database set up on your JC server yet. So at this point, it's probably best if you just kind of see what we're doing here. So what I'm going to do, so this is a tool called MySQL Workbench. It is a graphical development tool for working with the MySQL database. It is not the MySQL database. It's a separate piece of software. It's kind of like Dreamweaver is to a website. You know what I mean? It's the tool that you use to sort of code when you work with a database. So what I'm going to do is create a new connection. I've already got a database, and what I'm going to do is show you, we're going to connect to that and just look into it at this point. Yeah, so it could be. Yeah, if you're in this room, you might not be able to connect. Are you using the wire, Ethernet? If you use Ethernet, you might be able to connect. Remember my password here. Written down here on a piece of paper, hopefully. Another piece of paper. Okay. 0. All right, so I was able to connect. So I am connected. Let me see if there's a question in here. Question, should we download 5? Yeah, so if you're going to download this, download 5.2, which is what I linked to.
What is the difference between the MSI installer, the zip archive, and the zip archive? I mean, there's 3 things on this that you can download. So that I can.
On Windows, the MSI is the installer, the zip or kind of leaves the source code.
Yeah, I don't know. I would install the installer though.
Okay,
That's privacy.
We're supposed to set up and work with it, right?
You don't have to, I don't think, to download it. You could skip. There should be like a tiny little skip. Exactly. So they're polite enough to say no thanks. So it's not critically important that you start downloading and installing that now. If you are, that's fine. But let's look at what happens once you have, right? So the first thing you do is you create a connection. A connection, as you can imagine, is just a username and a password that will get you into that database. Many of you might not even have created a database account on the student server at this point. Don't worry about that. I'm going to show you how to do that in a minute. When I double click here, it should connect me to my account and bring up what's called a SQL editor, right? And what it does is it connects me to my schema, right? Remember I put that schema in when I logged in. It asked for my username, but it also asked for a schema. So a schema is just a set of tables that belongs to an account. Peretz, right? In my case, in your case, it's going to be by default. You're going to have a schema that is your first initial and the 7 first letters of your last name, or fewer, whatever that is. That's the username is not going to be that. That's your Unix username, but your database username is going to be that _admin _read write. I'll explain it. I'll explain it. So anyway, when I open up in this schema, you can see the tables that are in the schema, and you can see all the tables that are in my database. Right? You can't see this when you log in, but you can see it in mine. And this, in fact, all of these tables are what drives our website, our class website. Right? So everything in here. So let's say I wanted to see. Here you can see alter table. The problem with this interface is it's kind of tricky. Here we go. So the columns that are in the student table in a well-designed database should just be the specific information that has to do with a student. Right? An email has to do with a student. I know each of your email because you register in Kate, so I know your email. I know your first name, last name. This is information that you put in, right? Where is it? I believe your Git is information that you put in through your profile, right? So I went to the tables and I went to alter table, right? So I'm not looking at the data of the table. I'm looking at the structure of the table, right? If you think about it, you design a database by creating the structures of your tables, right? And then you populate the database by inserting rows into those tables with data into the columns, just like you would in a spreadsheet. So one of the things we're going to learn in this class, and it kind of makes sense, let's talk about it now, is this thing called creating a CRUD application. So we'll get into a little bit more of that next week. But CRUD stands for, does anyone know? CRUD, come on, everyone knows what CRUD is.
My first car.
Yeah, my first car. It's create, read, update, delete. Right? So the basic concept of that's something you probably want to know for the mention. Yeah, that's a good one. So write that on the wiki. So create, read, update, and delete. So the basic concept of making a database is creating first the structure. Here is a table, right? What I'm looking at here is the structure. You don't see the data in here. You see the structure of this table has these columns, right? That is the structure of the table. Then once we have the table, you could do only 4 things to a bit of data in that table. What does a bit of data in that table refer to? A row, right, as if it was a spreadsheet. So you could do only 1 of 2 things. You could create a new row. You could delete a row that's there. You can update it. Or you could just retrieve it, read it. Right? That's the only 4 things you could do with a database. So the SQL language, therefore, should only have 4 commands. Right? So let's see if that's a pretty good theory. Probably the best place to go is right here. SQL tutorial, the basic SQL tutorial, which is on W3 Schools. And when you go on here, let's see if they can find these 4. Here they are. The 4 nouns that are the basic concept of the SQL language. Select, which is read. Select, right? So you can issue a select statement. You could say, select column names from table. So select is the R of CRUD, right? Insert is the what? Is the C of CRUD, right? Create. When you want to create a new record, right? When Brett Pill is at bat, he sits down, he's done. Create, you would do insert. Insert a row into the at-bats table.
What's that? Insert equivalent to select is same as read.
Select is read. Well, if you're paying attention, you know. Insert is the same as what? C, right? We could do Y and C. So it's C, create. You insert, you create something. So you're inserting a row into a table. You're creating a new record. Right? Insert into X these values. Insert into the at-bats table, the batter, the result of the at-bat, whatever it is. The inning of the at-bat, the game of the at-bat. Okay. U is update, obviously, right? So this is the actual syntax. So structured query language, or SQL, is a new computing language, but it's not. It's simple. It's not like JavaScript or PHP. There's not a lot of fors and ifs and all that. There's basically a couple of statements: select, update, delete, insert. Yeah, the tricky part is telling it what to insert and what to delete. Correct. And the tricky part is to understand how the tables relate to each other. And the real tricky part is how to create a database where the tables relate to each other in an intelligent way. In a way that makes it easy to enter information into it, or data into it, in a way that makes it possible to enter information, get information out of it. Right? So what have we talked about? We talked about the fact that there is a database, which is a collection of data. And that's something that sits on your web server somewhere, or on a server somewhere. Right? We talked about the fact that the way you use it is by creating tables and designing tables that have columns that hold this information and in a way that they sort of relate to each other. Right? So, as an example, let's go back to this MySQL workbench. Here are all my tables: class, course, exercise, explore, homework. So before I went to start working at Oracle, I worked for this bank. And we bought this database system that was based on Oracle, which is how I learned it and ultimately went to work there. And what we were tracking was these bonds, savings bond. It was a bank, so we bought and sold bonds, municipal bonds, mortgage-backed securities, billions of dollars in bonds. We were tracking them on spreadsheets. that I wrote all these macros in. And we had the same issue, like what happens if something happens to a spreadsheet, or two people want to update it, or we have to print something out, or it wasn't the right way to do it. So we bought this relational database management system that we had a program, and we spent like a year programming it so it could track our bonds. Right? The guy that was the treasurer of the bank, he was a pretty smart guy, who bought and sold all these bonds. He was anxious because he wanted all this information. He kept on saying, when are you going to have this system up? And they would always say, why don't you just put it all on one table? You're creating too many tables. And that's exactly the wrong way to do a database. That's kind of the spreadsheet way, right? If I had built our class website with one table, it just wouldn't work effectively, right? I don't need to know everything in every table. I could just have them relate to one another. So to illustrate this, what I'm going to do is show you some of the power of MySQL Workbench. I'm going to reverse engineer my existing database into a data model, because and it's kind of hard to explain what that is at this point. So let me do it first. I did reverse engineer under database. I am back on the home page. Or I could do it anywhere. It's on the it's under database in the menu. So you need a database to do this. So okay.
It's not going to destroy the table that we already have, right?
Do you have a table?
Yeah.
No, it shouldn't. Hopefully. This is my whole database here. So what's it doing? Finish, finish, finish. As you can see, I didn't try this before, but there we go. Okay. So yeah, I can't show my diagram. I don't know why. That's too bad. The diagram part of it is pretty cool. It doesn't show it. Does it even show the table? So, yeah, sorry about that. It might show. It'll show it on Mac. I have had trouble getting it to work on Windows. Let me reverse engineered all these tables. So anyway, sorry about that. What I'll do is I will render that. I'll put out a screenshot of our class website data model, so you get a sense of how those tables relate to one another. But here, let me do this. Let me try to find a place where we could see a. Let's do this. MySQL data model diagram. Yeah. Okay. So this is a typical one. Right? Oops. Reverse engineer is to take a database and generate a model, and forward engineer is to take a model and to generate the database structures. So what is a model? A model is a drawing like this, where the tables are represented in sort of graphical images, and the relationships are lines between them. There's a special language called an entity relationship model, or an ER diagram. A model is to a database like an architect's blueprint is to a house. Does that make sense? You don't need a model to create a database, but if you're smart, you'd use one. Because databases change a lot more than houses do, and you're going to want to know what it looks like in some kind of graphical way. What role does a architect's blueprint play? It's documentation. It's documentation while you're building a house, and it's documentation after you've built the house, right? While you're building a house, it's documentation so everyone plays off the same page, you know? So the contractor puts the hole where the electrician has to put the wire, right? So they're all playing off the same page. Same thing with a database model. You want to get that right before you start building your applications, because your applications are going to interact with all of this data. You're literally going to write code. Select customer name from customer table. If somebody changes that, you're going to have to rewrite that code. So you want to get your data model sort of down and accurate typically before you start building your applications. And then you want to publish it so that if there's more than one application developer, they are using the data in the same way. And if there are changes to it, everybody could see it at the same time. So reverse engineering is taking an existing database and drawing the blueprint, which I just tried to do, but MySQL Workbench didn't really render the blueprint. They did create the model, but the picture of it didn't render for whatever reason. Colleen got it to work, but I couldn't. This thing. Yeah. So forward engineering is the more common thing you do, which is create the model and then generate the database. When you generate a database, you're generally creating not insert, update, select, or delete statements. You're generally creating a different type of SQL statement called a structural statement. And that would look something like create table. All right? So if we go, I shouldn't have gone all the way back, but if we go, oh, maybe that's the case. Yeah, let me go back and see that. But if you go to, where was I? Back to here, and you look at the create table statement. This is basically what those boxes in the model are going to do. When you draw a box, it's you saying there's going to be a table here, you know, but it's in a blueprint. It's just a drawing. When you forward engineer that model, it creates a script with a bunch of create table statements, one for each box. And then a column within that for each column that you defined in those boxes. Each one of these lines, it's hard to see, but each one of these lines is essentially representing a column. And then these relationships are basically interrelationships between the columns of two different tables. So the relationship part of it is not, you know, it's kind of advanced. I wouldn't worry about that right now. The point is, let's just do it. So let's do this. Let's get out of this model. Close that. Don't save. Let's get out of that. I'm going to connect to my database. And I think I could create a new schema. So let me try that. And let me see what the syntax is for that. So create. I don't think I could create a new database. But I think I could create a new schema. So let me try that. Create schema test. And then to execute, this is kind of a tricky interface. And let me say something about MySQL Workbench, this tool that I'm using now that you can get for free and that you're going to download to use for this class. It is very powerful. It's free. It's the only tool we can use. If it was up to me, we wouldn't use it. But for because it's something you have to install on your computer, there are tools that allow you to do the same thing through a server. There's something called PHP MyAdmin, which is part of the control panel and a different tool for doing what we're doing here. Very, very different interface. There's pros and cons to either one, but I'm just going to say right now, if you don't like this tool, it's not my fault. The college, this is the only one that they'll support. So we kind of have to use it. So you're kind of forced, what that means is to do this next exercise, to work with a database, you're going to have to download this tool and use it. MySQL Workbench. Right? So what that means is you're going to have to learn a new thing, all these buttons. So this lightning rod button is execute. So it took it. It said one row affected, whatever that means. But I now should have a schema called test. Right? So now I could use test. And what that means, a schema is a named set of tables. So I have one schema by default, which is this. But now I just created another one. If I refresh this, you'll see I now have two schemas. Right? And I'm working in this one. It's kind of highlighted. So now I could create new tables in this schema. Right? And I could create tables in one of two ways. I could create tables in a number of ways. I could create them in the modeler and then generate them by forward engineering. I could create them in this SQL window just by typing in the correct command. I've got to know SQL, right? So I would have to know this statement, create table, table name, and then the column names. And for each column name, there's a column type, right? Remember, when we had variables, variables have values and types. Well, databases, the columns are kind of like variables. They're a place to store data. So we need to tell it what type of data to expect. Is it going to be a number? Is it going to be a string? Is it going to be, what kind of data is it? Is it going to be a date? So if you wanted to do more research, you could look at all the different data types. In here there are dates, let's see where data types are. Data types. So another thing about the SQL language, which is basically what we see in this tutorial here. The SQL language, kind of like HTML, has a standard, and then it has Microsoft. No, I'm joking. It has a standard, and then it has companies that implement products. And as we know from browsers, sometimes there's a little bit of a mismatch. So here we see the access data types, and here's the MySQL data types, and there might be SQL Server data types, right? And there might be other implementations based on what database you're using. So there is a standard, but not every database really conforms to it. The standard is a little different, though, in that it's not defined by the W3C or by a standards organization that is sort of wishy-washy. It's defined, SQL is typically defined by the ANSI, the American National Standards Institute. So they're an actual government, they like say what a pound is and what an ounce is. So SQL is much more strictly governed as a standard. Doesn't mean everyone has to subscribe to it, but the government will only buy ANSI standard databases, and the government buys an incredible amount of databases, right? Your tax returns, all of that, where do you think it goes? Into some SQL database, right? So whatever it is, all these are gigantic users of data, large organizations. It's amazing. Like I said, I worked at Oracle. We used to sell databases. You would be amazed at the size and the complexity of some of these databases. The Latter-day Saints, the Mormon Church, gigantic user of databases. one of Oracle's biggest customers because they track genealogy. Not only for people of Mormon descent, but for everybody in the world. They want to create this gigantic genealogy database. The CIA, the CIA, like you saw in Argo and those guys, they created Oracle. Oracle, Larry Ellison started Oracle as a project to support the CIA as a way of storing every tidbit of intelligence information it gathered. It's any time a spy or somebody they thought was a spy moved, they would put it in some database. And that's what got Oracle started. The first project was Project Oracle for the CIA. And then they liked it so much they turned other government agencies onto it. And then, just about every government. The state of California probably spends $100 million a year on Oracle databases. It's incredible. Incredible. I mean, that's your tax dollars. So anyway, what was I saying? So there are standards, and the ANSI standard is the most powerful one, but there's also some differences between different implementations of databases. Since we're using MySQL, these are the operative data types. So there are text types, and they look a lot different than what we are used to seeing, like string. Right? So text types, for some reason they don't call it string. They call it varchar. And then you put a size in there. 25 characters, 250 characters, whatever. Right? Variable characters is what that means. But it's the same as a string. And you just define how long it can be up to. Right? Remember, you're creating a database table. So it's going to allocate memory for that whole, a database column within a table. So it's going to allocate how wide that column needs to be for the table. So you need to tell it up front not only what data type it is, but sometimes how large it's going to be if it's a string. And then there are different numbers, because it wants a size. Remember, these tables can get very large. Think of the at-bats table, at the end of the first day, let alone the end of the season, right? There's 24 teams or whatever. By 9 innings, how many at-bats is that per day in the major leagues? So you're creating these tables that can get very long, a lot of records. It's important, if you're a smart database administrator, to create the columns sized appropriately so you don't take up size unnecessarily in the database, but that you also don't, so you have enough room to store your information. So database administration, it goes beyond what we're even talking about. So let me explain that. Once the tables are created, there's a whole profession in just keeping these databases running on the disks and keeping them up on the network and all that. And large companies have teams of database administrators that do all this. At the JC, we probably don't have one full-time person. We might have somebody who's a system administrator that helps out with database administration. But at large organizations, the database is some of the company, if you think about it. Amazon, what are the assets of the company? It's the books they have on their shelf, but if they're smart, those will be shipped, as soon as possible. But it's that database of what products are for sale and who's buying them and the transactions, which are the meeting of them, So let's think about that for a second, designing the database. We're starting with Amazon. At a very simple level, think about the tables. You have a customer table, you have a products table, and then you have a transactions table. So we're relating them, right? So in the transactions table, do you have all the information about the customer? No, you just have the customer ID. In fact, what does the transaction table have? It just needs really 3 columns: date and time, customer, and product. Right? And that's what a transaction is. A customer bought a product and a price. But that price should be in the product table. Unless it was on sale, or they had a coupon, right? Or they're returning it, which is a negative transaction. Or they want it shipped to another address or whatever. So now you start to see, right now we need about 30, 40 tables, if you start thinking about it. But you could start at a high level and just sort of abstract broadly. And say, I could invent Amazon, or I could invent an e-commerce system. At the end of the day, a transaction is just the intersection of a customer and a product. So I'm going to have a row for every customer in my customer table. I'm going to have a row for every product in my product table. And then I'm going to have a row for every time a customer buys a product. And they just have to point to those other tables, or those rows in those other tables. Does that kind of make sense? So, but like I said, there's a lot of complexity within that. And typically Amazon, let me put it this way, to create our little website where I could tell you what the homework is and give you a little bit of reading and you could, submit your homework and all that, that's 11 tables. From a pretty tightly designed, I might have been able to do a little bit better, but a pretty tightly designed database. So that, and that doesn't track every, I don't know what your address and all of that, it's just tracking what we need to run that website. So just to give you, an example of the scale of databases, but Amazon could be thousands of tables because they've got a complex business, but their products should all be in one table or one virtual table, right? Because if not, your application gets a lot more complex. Like I said before, do you want to go to the housewares or the books or whatever? Having it all in one place makes it easier. You could cross-sell,
It would be different tables that they were setting up, clothes, houseware.
What if you want to do a search on anything about, pick a pizza, and there could be things about pizza and houseware. There could be books about pizza. There could be movies about, what was her first movie? Julia Roberts, Mystic Pizza, right? So you want to listen. So if you want to do a search on everything about pizza on Amazon, you could do that, and it goes across all products. So putting that in different tables isn't a great thing, And there are probably, 40 PhD data analysts at Amazon constantly working full-time to design their database so it, one, has information that they can get to very quickly, and two, so it's performant, so that when you enter a transaction in, if it has to go to 1,000 tables to do your transaction, you won't wait to get that confirmation back, you know what I mean? So there's a lot, like I said, there's two main professions just outside of the web developer in managing a database. What we're doing in this class is giving you sort of a survey of what it takes to build a database-based web, but we could go a lot deeper in MySQL, right, and databases in general. So we're going to take a break, and then we're going to get back and create a table, and then we'll enter some information in the table. And if we have time, we'll hook it up to a PHP program. If not, we'll do that next week. Or we'll start to do that next week. So any questions about, we still have those people home? Plans for building, right? Any questions in here? Any? Nope. The loss. Guess no questions. All right, so I'm going to stop the recording. Let's come back at 8:33, and remind me to turn the recording back on. Yes. When will you assist us to set up MySQL? Oh, I'm going to do that when we get back. Very good point. So I will do that when we get back. Can I use my own PHP admin database? You can do that. You can use your own web hosting company or your own database on your own web host. That's fine. As long as I could see it, and as long as you could support yourself, that is fine. My question is, Cal. Good question, Cal. Jay, Where does GitHub fit in all these days? As I go through the past lectures, my thoughts get scattered. By the way, I've used them. Where does GitHub fit in these days? So GitHub is still another tool we're using. It is managing your code. That's a, think about that. That's a different, it's just another tool we're using for you to manage your code and to share it with me. So you're still going to, when you do your projects, you're still going to use GitHub. MySQL Workbench is a completely different purpose. It's a development tool for setting up your database. We are just answering questions that people have.
I didn't want to see that. I wanted to, like, on Access, you get this great visual picture with all the lines and everything. And we just did that, but it didn't have the lines from the index before. It was really.
Yeah, I might go back in there and see.
It just put all the tables on top of each other.
So you think it worked? If I go here, and I go here, and I do reverse engineer. See, it did see my other schema, right? Execute it. It never really lets me finish. I don't know why that is. Well, I did, but it never finishes. But that's okay. Here, if I get out of here, and then I go in here, you're saying that they're on top of each other?
Yeah.
But where, like, how do I... But how come I can't see them? Yeah, I see that, but I can't see them on here, you know? Maybe my preferences are put everything in blue. You know what I mean?
See if there's anything you ever edit preferences.
Yeah.
That diagram.
Expand new objects. I don't know. Let's see what happens if I do that. Yeah. MySQL Workbench is a cool tool, like I said, but it is it's not designed for Windows 7 or whatever this is. It's I use it all the time. I use it. Yeah, I use it. Oh, I do. Yeah. For me, it's more intuitive. But like I said, you have to. It doesn't work that well on all computers. It's kind of a lot of software, so it's look at the I don't know what it's doing here. Yeah, I don't know what it's doing. So it is, unfortunately, we do have to use. Excuse me. We do have to use it for this class because we don't have a choice. It's the JC database administrator. That guy I said isn't full time. He doesn't think my PHP admin is secure enough, and thinks that this is more secure, which I don't really get. But anyway. So somebody in the class that has an account on the JC server that hasn't set up a database yet. Any volunteers? I'm going to sell you in half. That know your password, Unix password. Right. So it won't let you create a new one, so don't try it. Maybe I have special I just have a student account. I don't think so. So how do I get to a shell program on here? What is it? Anyone know how to do like a shell program? Type it where? Here?
Yeah, first you bring it up to command line.
Oh, here we go. Okay, so I should be able to go telnet, and what's your account? Why don't you come up here? Yeah.
Just screen it out.
Yeah, because you don't need your password. It's like, I don't know.
So just my username.
Username at student.
Oh,
That's Santa Rosa. .edu.
yeah, that's it.
Yep, try that. Hang on. It's not telling it. It's
Oh, hold on. It's actually 8/3.
alright.
But that might have been it. You could try to tell that one again. You just press up.
Yeah, I don't think telnet will do it.
You could just press up twice, and it puts it. Yeah. Alright, and then just change it. That's it. Yeah.
Yeah. There's something I have to install to get this. Yeah, something like that here. Putty, that's what I need. Download. Where's the legal warning, binary. Contain all the Windows installed for everything except. What's putty tell?
Just up above that where it says Putty, you have the Putty PHP up there.
This one right here?
No, up further.
Right there.
This one?
Yeah.
That's all I need?
Yeah, that should be the entire.
Alright.
Okay.
And I should just be able to start this? Alright. Okay, so I want to create a session. So it's
So we need to do this on our computers too.
yeah,
How do you think?
yeah, you don't need to because I'm doing it for you. SSH. Okay.
But I have to do it on that one if I want to connect.
No, once I do this, we only have to do this once. Everybody has to only do this once. So I'm going to do it for you.
Okay.
Is that all right?
Yeah.
So, but I'm not going to do it until we get back to the class.
What's the Putty interface look like?
It's like this.
Yeah, so it just brings you to command line.
Well, it's
You don't
like,
need this.
I thought it was a...
Yeah, so how do I start it up again? It should be...
So I don't know if it
It
installs.
might be on the desktop.
Putting downloads.
Yeah, I guess.
Yeah. And so I could put it just on the desktop. Okay, so you want me to...
We try it once and then just run through. So the host name is students at students.santarosa.edu, port 22.
SSH, default setting, open, and
Okay,
then...
now you're there.
Cool. All right. Now we're gonna quit. We're gonna do that again in a second. All right.
I remember something about like www.
Yeah, you already did that.
or something.
Yeah,
Oh, okay.
yeah, you already did. So hang out here for you don't have to hang out here the whole time. I want to start it out.
So now I can go back.
Yeah, I'll call you back in a minute though. Unless you want. Why don't you just write it? I can get to it anyway. I really want to.
Oh, I can change it too. So.
Did you change it from the default?
No, it's
Yeah,
still
so just put the
default.
default. Yeah.
But I mean, I can change it anytime.
You could, yeah. Just remember what you changed it to. AT, capitals? Okay.
Yeah.
Thanks. And once I do this, you don't have to do it.
So it doesn't matter which computer.
It's only a one-time thing. Yeah. Doesn't matter what computer you're using. Okay. It's time for the class again. A long chat here. Okay, we're just about ready to get started. So, what we're going to go over now is how to set up a MySQL account on the student server. There's only one, you only have to do this once in the lifetime of that account on the student server. If you have already taken a class at the JC that uses a MySQL database, which could be the MySQL or the PHP class, or you might have taken this class before, or for whatever reason, you don't need to do this, because that account can only have one database account, and if you do this twice, you mess up your database account, and unfortunately you have to drop this class. So, because there's no way to fix it. Now, there's a way to fix it, but you have to ask Walter to fix it. Walter Chesbrough, who's like the IT guy for the whole student body. So you have to get on your hands and knees and beg Walter to fix your account if you do this twice, or if you forget your password. So when I do this, I am gonna. You might have set this up for a previous class, but if you forgot your password, you have to drop this class in front. No, I'm joking. You have to go to Walter and ask him to reset it. So I'm going to show you this now. You only need to do it once, and it's very, very simple. But so let's get going. So on a Mac, yes, I'm back. I don't think I ever stopped the recording. It was one of those days. I don't think I ever. It is recording. I don't think I ever stopped it. So, so what we're going to do, so the process is the same, although the tools that you use are slightly different on a Mac than they are on Windows. If you're using a Mac, the Mac operating system, which is really based on Unix, comes with a program called Terminal. And you could do this through the Terminal interface, right? You just open up Terminal, and then you type in what we're going to type in here. If you're using Windows, then you need a SSH client on Windows, a secure shell. A shell is sort of a client command line interface, and a secure shell uses encryption because you're going to be getting a password, so they want to encrypt it. So you need a secure shell program on Windows. On a Mac, secure shell is part of the operating system. So you open up the terminal and you type in SSH, and it starts up the secure shell. So on Windows, I downloaded a little tool called Putty, P-U-T-T-Y. And I just literally downloaded it on this machine. I just literally typed in Putty. Well, what I typed in was Windows SSH. I didn't even know I was looking for Putty, but this popped up, and I downloaded this little program right here, and it seems to work. And when I do that, it gives me this program, and when I click on this program, it says, "Are you sure you want to use this?" And I say, "Run it." Right? So I should have something like this. If you're on a Mac, it's going to look differently. Terminal will be just a blank screen. So when I get home tonight, what I'll do is record a video on how to do this, how to do a secure shell on a Mac. Right? So the host name you want to connect to is student.santarosa.edu. And we want to select SSH, which I don't need to select because it's the default. And I can hit open. And that will bring up something that you might, can we use SSH secure? Yep. If you have another way of getting a secure shell from Windows or wherever you, that's fine, right? But you need a secure shell connection. Can I back up one step? Let me back up one step. I go to PuTTY, I run this, I type in student.santarosa.edu, and I click open, and it brings it up. And now it asks me, who do I want to log in as? This is your account, right? It's your 8-letter or fewer account, your first name and your 7 letters of your first initial. So I'm going to type in our brave volunteer, and I'm just going to type in his name. On a Mac, what you would type in is SSH space, the username, aTorres3 in this example, and then at student.santarosa.edu. If you're using a Mac, you can type that right from the terminal, and you'll get to the same place as right here. It'll ask you for your password. It's the Unix password that it needs. So that one with your student ID, your 2 initials, and then your student ID. It's not going to show your password in case the guy behind you is watching, so it's protecting you. And when I type it in, it should give me something like this. It says, you are now signed in to bizapp03.student.santarosa.edu, which is I don't know what it is. It might be an alias. But anyway, here's where I'm logged in, is right here. And I got what's known as a Unix command line shell. All right, I am logged in. So this is where the fun starts, okay? Watch very carefully. Okay, watch very carefully. Once you've gotten to this place, whether you're on a Mac or you're on a Windows, you're going to be at this SSH spot with a command line, and typically the command line will even show your name, show you who you're logged in at. You just have to type in one command. You might have typed in, way back when you started at the JC, you typed in www.me to create a web account. You might not remember that. If you don't, that's fine, because you've already done it. It's done. What you're going to type in now is SQLME, SQL me. In other words, give me a SQL account. And when I type that in, well, it didn't work. No, it is, I think I have to type in sudo, thank you, SQL me. And that will give me the permission. This is a Unix command. Let me say this again. You only ever have to do this once in your whole life of this account. So you don't really have to remember this, but this is a Unix command that says, switch the user so that I can do this, and then do this, which is run a script called SQL me, which is going to create an account for you on the student server, a special account, a MySQL account. So when I type that in, it ran. And I get a whole bunch of passwords, because it didn't just create one account, it actually creates a set of accounts that all point to the same schema. The schema is going to be the same as your Unix ID, right? And all of these passwords, you kind of have to save. Or, like I said, you have to drop this class if you lose these passwords. So the best thing to do is to copy them and email them to yourself.
So can I change them?
You can't change them. So once these are created, I don't think there's a way you could do it. I don't think we have the privilege in the MySQL database to change our own passwords. I think they're generated for us. Okay, so what I would do, I would copy it and email it to myself. You can just go like that. Just select it and copy it. So I am going to send mine to my friend here. I'm going to need your email address. How do I don't know what it is. Yeah, I could do it. Yeah. Let me do it now before I forget. Okay. So, new message. Settings.edu. Did I get that? Something to myself just in case. And I'm going to go back here and grab all this. And it says if there was a problem, send this to your teacher. They're not talking about me. I'm not joking to help you if you had a problem. But yeah, do send it to me if you do have an issue here. And I'll see if I can get Walter to help you. So there's an admin user, there's a read-write user, there's a select-only user. So you get some insight into how MySQL works in terms of data access privileges, right? You could set up different accounts with different privileges that have different, some of them could update the database, some of them could just read the database. Some of them could create new tables in the database. For the purposes of this class, and for simplicity, I would always use the admin account. So the rest of the stuff you really don't ever need, because the admin account has all the privileges that these accounts have, plus more. And the purpose of this class is not to teach you the different privileges. We're just going to assume that you have full privilege to the. You should be able to see the value in having different users with different access privileges, but you don't need to use it for the applications we're going to build in this class. So all you really need is this admin. But I am going to send you all of them because they're your passwords.
Oh, I see it now. I'm going to copy it real quick.
So it's not, let's see, come on. You must choose a recipient. So,
Put a semicolon in between it.
yeah, I tried, but it wouldn't let me even.
Then just CC yourself on it.
Yeah, no. Okay. All right. Lots of noise on viscous. Always good to see. So so it looks like the only user that can utilize CRUD is the admin. Yeah. So that's a good way of thinking about it. To get full privileges, the admin can do both create, read, update, and delete. And different users, like the read-write user, could probably do that also, but maybe not create a table. Do you see that? The C in CRUD is for creating a row, really. You know, But then there's creating tables, which I don't think that the read-write user can do. The RW stands for read-write. So that was one question. Will the SSH secure shell client users work for this? Will the SSH secure shell client? Yeah, I don't know which. I think they use PuTTY. But yes, any secure shell will work. What you do need is a secure shell connection to the student server, and once you do that, I just happen to use PuTTY because it had good SEO. It was the first thing that popped up when I typed in Windows SSH. So I think that works. I think that answers your question. You already figured it out. Can we use SSH secure? Yes, you can. So okay, so let's reiterate this because it could be people listening at home later or whatever. You only need to do this once, and this only sets up your database accounts. Doesn't create any tables, doesn't do anything like that. But once I have this set up, I should be able to log in and create some tables. So I'm going to log into, I'm going to copy this. Oops. Get out of here. I think I copied. Well, before I get out of here, let me see that. And what I'm going to do is go back to MySQL Workbench, and we could get rid of this. Don't save. And now I should be able to create a new connection with student.santarosa.edu. The username is Torres3_admin, right? And the default schema is going to be Torres3, and the password is going to be. Well, I pasted. I created a new connection, right? Let's see. There's a question on the board. Wait a minute.
So I actually sent an email to my student account automatically.
Okay, good. So that is a feature. So you already have, by virtue of that account, an email account, you know, abc@santarosa.edu by being a student. And when you do SQL Me, it sends the password. It sends the passwords to your account. So you've got two passwords. You got two emails. One from me. Oh, so you didn't get mine? Yeah. All right. So, okay. So when I go in here, I can see that I've got the schema, but there's no tables in here yet. All right. So what did I do? I created a MySQL account on the student server by typing in SQL Me, sudo SQL Me, sudo space SQLME, and then I set up a connection in the MySQL Workbench so I can now access that account and work with it. I could create tables. Right? So, like I said, there's a couple of ways we could create tables. We could start with the drafting. You know, we could model a whole database or even just one table and generate it from there using forward engineering. Another way we could create a table is if we know the syntax in SQL for creating a table, and we know all the syntax that goes into creating a table, we could just type it right in. So we could, here, create a table. So here's the basic syntax. So let's go back to MySQL Workbench and just say create table. And let's call our table contacts. Okay? And then let's put a column in here. So let's create a table that is going to store, remember that contact form we created last week? I'll get to that question in a second. Last week we created a contact form and we had that go to email. we could also have it create a record in our database. So we could store it at the same time we send an email. So we would add 3 columns here, right? We'd add maybe name, and we'd add, what else? Email, and we'd add telephone maybe, right? And each of those would need a data type. So we go like varchar 25. And this would be a varchar 50, let's say. And telephone would be varchar. Why would I make telephone a varchar? So I could put dashes, exactly, or, and that might be, let's say 20, maybe even with an international. And then if I execute this, I got 0 rows affected because I didn't really change any rows, but I have a new table called contacts, right? So let me go back to see what might be some. Can you show the login for the MySQL in? Okay, wait. Yes, please. Would you please repeat workbench? Okay. So the splash screen, the welcome screen to the MySQL workbench, has 3 main areas. Right? This area we're not really going to use in this class, and even this area we'll have to see if we get to modeling. It's not an important component of this class. We'll talk about it like we did today, but not a big part of it. Most of what you're going to be doing is creating a connect in this welcome screen, which is what you first see when you launch it, is to create a new connection, or once you have a connection created, to just double-click and connect to a database using that connection. Right? So I have a connection open here for the new account I just created for Mr. Torres. I'm sorry, what's your first name? Tony? Okay. So, and now I could also connect to my database schema, right? Just by double-clicking on that. So these are pre-created connections, and they sit on this computer. If I go to another computer, they're not going to be there. They're just saved locally, right? But to create a new connection, you would click on a new connection tab, this thing, and it will bring up this window. And you could name your connection whatever you want. And then you could put student.sanrosa.edu right here, where it says hostname. Where it says username, you would put the MySQL username. That would be aTorres_admin or _read_write. RW would also work. But the MySQL account name. In here is the schema name, which is the same as your Unix name, your login name, the 8-digit name that you got from the JC, right? And your password goes in where it says Store in Vault. You click on that, and you type it in there, and you save it. And then it stores it in a vault. I'm not sure what that means, but it looks secure. Okay, in this classroom, at home there's not a problem. But I believe this classroom, if you're using your own computer and using the Wi-Fi network, port 3306 is probably closed because of the paranoia of this college. So you could unplug the Ethernet cable from the computer and plug that into your computer, and I think if you're using Ethernet, it'll allow you to use 3306, but I can't even guarantee that. I know that works for FTP, but I'm not sure that they fixed it last year. I'm not sure they fixed it this year. Question?
How do you think the program will say for this program or
Okay, so a port number is a special address on the server that you can you can tell the network to use to access a special service or protocol. So when you say Dreamweaver uses 22, what you're really saying is FTP is the standard port for FTP services on a server is 21. The standard port for secure FTP services on a server is 22. The standard port for SQL, remote SQL access on a server is 3306. Remote SQL access meaning you're using a client piece of software that's going to connect to your SQL software, kind of like FTP does, using a special SQL protocol. So 3306 is a standard on servers. MySQL Workbench puts it in here, but your administrator on a certain server might change that, and they'd instruct you to, and you just put that in there. All right, so those are the port numbers, and they're standards, but they can be reassigned. And 21 is the standard for FTP. 22 is for the secure FTP that we use for Dreamweaver in this class. Does that answer your question?
To back up a little bit, I kind of missed exactly where you did that. SQL beam, is that?
Way back then.
I know,
Okay.
I do this on an ancient machine.
Yeah. So
I get to I log into the
so you have a secure connection.
secure connection.
So it looks like this. You've got the student.
It just, I'm in my directory and it says public HTML. When I do an ls, it just says public HTML.
That should be fine, right? If I do that, yeah, I get the same. Well, I get some more, but yeah. So that's good. So SU. So you want to type in sudo SQL me. SUDO space SQLME. It'll give you. It'll print out all these passwords on the screen after it creates them. Did that happen? Don't lose those passwords. Send them to yourself. Are we using, so a couple of questions. Host name is correct. Would you please, okay, so I'm doing that. Host name is student, that is correct. The host name is student.sanarosa.edu. The port is 3306. Which you shouldn't need to change. The port pertains to the service, not to the server. I'm sorry, question? You can't connect using MySQL Workbench? Yeah, so it's just a network thing. And sorry about that. Yeah, you could use the Windows computer here. That probably will work. But that's up to you. For some reason, I have someone's data modeling on the splash page. So that might be just an example. Unless you've used it before and they have an example. Yeah, I don't know. I don't know where that's coming from. Let's see. I have somebody else. Workbench, excellent things. Can we create a new schema for each? How can we create a new schema for each class? It looks real. It looks real. What connection method in Workbench? So it shouldn't ask you for a connection method. Come on. It shouldn't ask you for. I don't think it should ask. But if it asks, you're using standard oh, here it is. So yeah, you're using standard TCP/IP. Yep. TCP/IP. Sorry. So other questions? What connection? Same here as I have one too. I'm not sure what that means. It has standard or SSH. So you want to use standard TCP/IP. How can we create a new schema for each class? So I don't know what you mean by that. For each lesson, you probably don't want or need to create a new schema. If you're taking another class that's going to use the same database, you might want to create a new schema. And to create a new schema, I have a DB for another class. So to do that, you would go to your SQL command, and you would create a new schema. I kind of did this before. I created one test, so let's do create schema test 2. Access denied. So yeah, maybe you could only do one, or maybe you only have one schema in addition to your default schema. So, but I was able to create one, and let's do this. Let's delete. Here, let me do this again. I have a schema. I have two schemas. I have a schema with my name that came by default. I have this one. I'm going to right-click on this and do drop schema. Oh, I don't want to do that. Bye-bye. Bye-bye. I'm going to go over here and do drop schema. It not only says, are you sure you want to do this, it actually gives you the SQL statement, right? Remember what I said kind of at the beginning of this class. A database has to be spoken to in only one way, SQL. That's the only language it understands. Whether you're creating a new record in PHP, or even if you're using this MySQL Workbench tool, at the end of the day, all this tool does is create statements that get sent to the database. Does that make sense? So I could just take this statement, copy it, get rid of that, and type this directly in and run it. Database doesn't exist. Maybe I already deleted it. Yep, so it's deleted already. So now I should be able to create it. And now when I refresh this, I created it. So now can I create a second one? It didn't let me before. Yeah, I only seem to be able to create one schema. So I don't know why that is, but you shouldn't need more than two, I don't think. So I have a new schema called test. Refresh this. Huh, it dropped it. When I try to create a second one, it drops my first one. Look at it. Okay, now I'm going to try to create a table in the test schema. Right? So, like I said, I started typing before. You could actually type out the create. Do I still have it in there? No. The create table syntax. A better way of creating a table is, let's go to changes, is just to go over here, or let's do it in my test schema, and nope, thought I could create a table there. Let's go create table. Right? So I selected this schema. I opened it up so I could see the tables. I go to table and I click on create table. When I do that, I get an interface that allows me to create a table. In other words, I don't have to know all the syntax. Here. I don't have to know all the syntax. I've got a visual editor that creates a table. So the first thing I'm going to do is give the table a new name, right? So let's call it, like I said, contacts. We want to store every time somebody fills out the contact form, right? Remember from last week. So the table is going to be called contacts. And the table needs a column, right? Every table has to have at least one column. Without a column, it's not a table. You know, You need at least one column. Just like, what's an analogy? I guess there is none. You don't have a table without at least one column. That's our rule. So one will be the name, right? So I would put customer name, right? And where it says data type, I would choose a varchar. Remember I said before, that's kind of a SQL way of saying string. And you always give varchar a length. So for a name, I could give it 50, right? It's probably good enough for a first and last name, right? Now these are very important, right? They're not easy to understand just looking at them, but they are very important. Primary key is what PK stands for. NN stands for not null. So these are what's known as constraints, rules. Can you have a customer without a name? If you can, then you could turn that off. If a customer has to have a name, and you would say it can't be null. And then you cannot, the database will not allow you to enter a row, no matter what you do in coding your application, other than creating a fictitious name. No matter what you do, the database will keep that integrity and not let any application create a new record in that table unless it has a name in it. Another beautiful benefit of using a multi-user database, relational database. It has referential integrity. You could put rules in there very easily, and those rules are enforced in the utmost way they can be enforced. In other words, it's not going to happen unless you have this, no matter what you do, because the database only speaks SQL. There's only one way to get that data into that table, and that's to issue an insert statement. And an insert statement won't let you do that if you put not null here and you don't pass it the customer name when you insert a new record. So does that make sense? In terms of the logic and the power that gives you in developing large applications. The database administrator makes the rules and all application developers have to live by them, which is good, right? You don't want application guys coming up with their own data rules. You know, some people will put first name, comma, last name. Some people will put last name, comma, first name. The people in Japan will put everything in, you know, up and down. Not so, you know, everybody has their own rules for data, but you want one database that has all plays by the same rules, or it won't make sense. When you go to print, you know, bank statements, you need to know what's the first name and what's the last name, and in what order do they go. So the point at this point is that we have the ability to enforce rules at the data level, which is the utmost guarantee, because no application can override that. A primary key is a special type of column. It's a column that is guaranteed to be unique. It's kind of like an ID on a web page. It's a unique identifier. And it's something that you can always guarantee will always be there and always be unique. There are some primary keys in the real world, but there aren't very many. So usually we make them up, although there are some. So what would be a primary key in the real world? How can you identify yourself to a primary key? A VIN number would be a primary key for an automobile or a vehicle, right? A social security number, exactly. Your fingerprint. Yeah, if it could be digitally rendered, it could be used as a primary key. And it could be digitally rendered. You just have to come up with some encryption for it. Right? I don't know if they take your fingerprint and digitalize it. They might. Your email address is what I use in our class website for primary key. We could have, you know, 2 Andrews in this class. We could even have 2 Andrew Smiths in this class. We could have two Andrew Carnegie Smith III in this class, you know, but we could only have, they have to have separate emails, theoretically, unless they share it, in which case they're only getting one grade from me. In which case, yeah, that's a different story. But an email, as you could think of, is a primary identifier. You know what I mean? I have the same number of emails as I have students, almost. Maybe not, right? So think about it. I could have students with multiple emails, which I don't accept, at least for this class. I could have students that are taking two of my classes. So I have one email, but I have to give them 2 grades, right? So, you know, there's different rules, but in the student class, I wouldn't want to have 2 different rows for them, you know what I mean, in the student table. So the point at this point is a name wouldn't make a perfect primary key, an email might. However, you know, for our application, it's a contact form. So we don't want to use email because, you know, what if the person sends us an email on Monday, we're on vacation, you know, they send us another contact form on Thursday. I really need a gardener. The grass grew another inch. Where are you? Get back to me. So, you know what I mean? We don't want to lock out that next transaction. So we would typically, like I said, in almost all cases in a relational database, you kind of create a primary key because you can't always guarantee uniqueness. So when the thing is inserted, you can create a primary key. And the way you do that is you can just create a contact ID, just give it a name. And I would call it the best way to guarantee uniqueness is with an integer. It's not a number data type. SQL is a little bit more complex, and there's different types of numbers. So we're just going to use an integer. If you think about a serial number or a phone number, are just really structured integers. There are different data types for numbers, but an integer, you know what that is. That's a whole number that's not negative, starting at 0 and moving its way up. And I'm going to say that is our primary key, and therefore the primary key can never be null, right? And the trick in MySQL to create a primary key is to click AI, which stands for auto increment. So by clicking that, you never have to tell it what to insert in that column. MySQL will create a serial number that it'll put in that column and guarantee uniqueness for that table. There are times when you want not null, but not to be unique. You know what I mean? When you want not null, might be, do you want this shipped by UPS or USPS? So it needs to be filled out, but it doesn't need to be unique. That's very different than a primary key. A primary key is always not null, but not all columns that are designated as not null are primary keys.
Right, but aren't all primary keys also auto-incremented?
No. An email could be a primary key that's not auto-incremented. I'm going to tell you what the primary. So, like I said, in the real world, sometimes God gives you a primary key. And, you know, if Amazon, so let me think about this. Why do all websites now use your email address, allow you to use your email address for login? Remember, they used to always create a username and a password to log in. Now, a lot of times you can just use your email to log in because it's always guaranteed to be unique. Whereas you used to enter a username and they come back and say, somebody already has that. Try HRS3, you know what I mean? So email will always be unique. So, you know, the world does give us some unique identifiers that we can use for primary keys, but not always. And when we don't get one, we can create one artificially using artificial intelligence or auto increment, same initials. But it does, you know, what it does is, we'll see it in a minute. I'm going to insert a row, and you'll see that it'll give you an automatic incrementer. So we have a name, and let's just give it a email. And that'll be a varchar 45, and we could say that that should not be null either. Right? I'm not sure what these mean, to be honest. So if it's numeric, unsigned data type is a binary column, unique index. For the purposes of this class, primary key not null and auto increment are really, what we would use. And then, if we hit apply, what happens? SQL Server has gone away. I talked too much. So it won't let me apply these changes? There we go. Preparing. All right. So let me do this. Let me connect again. Sorry about this. Like I said, MySQL Workbench is kind of a cool tool, but it's a little flaky. Okay. So that schema, I think what's happening is every time I create a schema, it blows it away. I don't think I created that test schema, but it's gone. So what I'm going to do is I'm going to use your account temporarily to create this table. And I'm going to do that all over again. So for those of you who want to see it again, you're in luck, right? So the table is going to be called contacts. And when I go to, okay, watch this. When I just click on, before I even enter anything, if I click on the column area here, it kind of creates a primary key for me by default. That's how smart MySQL Workbench is. It sort of says, every table needs a primary key. I'm going to create one. If you don't like this one, override it. And before, you didn't see it, but I actually overrode it. I deleted that. But I'm just going to let it keep it. It doesn't do the auto increment by default, so I'm just going to click that. And then I could just put name, make that a varchar5, and email, make that a varchar5. These could be not null. And when I apply this, I get, before it creates it for me, it shows me the SQL, the SQL statement that will create that table, and it allows me to apply it. Right? So I can literally take this and copy it and apply it through the SQL window, the SQL editor, or I can just apply it here, and if the SQL was correct, if there was no other table with that name or there was no other problem, it'll create it. And now if I look under my tables, I should have a, well, somehow it created this one. Did you do this? Maybe I did it before. So, yeah, this is the one I created now. That's one I created before. I'm going to drop that. Okay, so here is our table, and here's our, if I right-click and alter it, I'm going to get that interface back, right? The visual editor of the table structure, right? Which I don't really want to change right now. If I double-click on the table, or actually that doesn't work, if I edit table data, what I'm going to get is a tabular spreadsheet-like interface to this table, right? Where I can enter data, right? So I can enter a name here, right? I can enter Joe Smith at gmail.com, right? And then I could, to submit this data, I think it is apply. That will give me the SQL statement. And when I run it, that data is now in there, right? So I could get completely out of this and connect back, get back to that table, edit the data, and that record is still in there, right? So that just shows the number one. I didn't even say what that feature was, but the number one basic feature of a database obviously allows you to store data, store it persistently, right? The data will always be there. This session goes away, this local computer goes away, that data is stored on the JC server. And theoretically, somebody's backing it up, it's always going to be there, right? So it's known as persistent storage, right? When you're working on a website, the persistent storage, is an important concept, right? Once things are stored in there, you can bring them back into the website to see them. Right? So what have we done at this point? We've learned how on the JC to create a MySQL account, number one. Number two is we've learned a little bit. Most of you, or some of you, have had the chance to download the MySQL Workbench tool. You learned how to create a connection to the account through that. You've learned how to create a table, and you've learned a simple way of entering data into a simple table. Right? Now, let's do this again, real quick. Now, I didn't enter an ID, but the ID is there. Did you see that? That's the auto increment. So let's do another customer, Jane Smith, and this will be no relation, smith@gmail.com. And when I apply this, I get this statement right there. So let's copy this first. Undo that, copy that, apply that, finish that. So now I have two records, and Jane has an ID of 2. So you see how the serial number works. Just like a serial number, 1, 2, 3, 4, whatever. What was I going to show you? Oh, here. Let's open up here, let's do this. Get rid of this. Get rid of this. So what I'm going to do now is paste the SQL statement. It's hard to read because it's on multiple lines. But this is the SQL statement that was generated when I inserted Jane in the database. Right? It's a little hard to read these yellow. But that's basically the SQL insert statement. So the point is, what we're going to get into next week is this. W3 schools PHP MySQL. Yeah. Okay. So remember I said before that PHP is a programming language that has an extension for working with SQL. So it has a set of functions for allowing you to interact with a SQL database. So basically what we're going to learn next week is how to use these functions. And the main one is going to be something called query right here. So can't just click on it, but let's see if we could find a here. So the reason I'm showing you this is to kind of give you an example or start to show you how this all comes together. So this should look familiar to you, the PHP tag and the closing PHP tag. And this should look very familiar to you. It is what? This is starts with a $sign in PHP. It's a variable. And we're assigning something to that variable. We're assigning the result of this MySQL connection function. So, and this should look familiar to you. This is the host, the account, the password and the schema for your MySQL database. So, Tony, you already know this. You know this is student.sanjose.edu, HRS3, your password, and then, or HRS3 underscore admin, and then HRS3, and then whatever your password is. When you do this in PHP, you now have a connection to your database from within your PHP program. And then you could test for that connection. If it didn't work, you test for it, and you say, well, that connection didn't work. I must have the wrong password. You always do that because if your program can't connect, you want your user to get some feedback. You know, your bank transfer didn't happen or whatever. You know, your reservation for the Rolling Stones at Candlestick Park did not go through, or whatever it is. Right? So, but here you can kind of see we create a connection. That connection now has a handle and a sort of a digital ID that we're storing in this variable. Right? Then we can pass this second function, which is the query. That's where you put your statement that you want to send. Right? In this case, we would replace this with persons. We would replace it with contacts, and with the data that we want to enter into the database. We might want to enter 2 records into the database at the same time. And then we would close our connection, and that data would then be in the database. So that's how PHP and SQL go together at a very, very high level. Right? We saw how to insert a record using MySQL Workbench, but nobody really does that. You know, Amazon doesn't have squirrels using MySQL Workbench entering book orders, you know, in Seattle. You enter it in a, you know, you fill out a form. It takes that data, it puts that in the SQL database, and it uses something very similar to this. They don't show you the code because it's in PHP. It's on their server, and they have a whole bunch of code that figures out if you're logged in, and if you have a coupon, and you know, all of that stuff. But at the end of the day, this is basically how it works, right? You know, Facebook, same thing. You know, it knows that you're logged in. If it has a SQL connection, it says insert a, you know, like next to this picture of my cat, or whatever it is, right? Picture 1,647,400,000, whatever the ID is of that picture. Right? So we've see if there's any questions. We've kind of wasted another good 3-hour session here. Anyone know the driver and URL for connecting to the database in the very beginning of Workbench? So so to connect, do this again, to connect the driver, I don't know, I think it's going to be TCP/IP. And I think you might be talking about when you're downloading it, the question online, and I think you just want the basic TCP/IP version of MySQL Workbench. I think that might answer your question. I think these are from before. Any other questions? We covered a lot in this. It might not seem like it, but we covered a lot in this class.
You know if SQLite will work for this?
SQLite SQLite is a fully compliant SQL database that is not multi-user. It runs on a local computer, kind of like Access. But it's a lot. Access doesn't really use compliant SQL, whereas SQLite does. SQLite is a product by a company called Sybase, which I think is now owned by SAP. So you could use it for this class. It's hard to use SQLite for a database for a web server because typically it runs like on a local computer. So where SQLite is used is for sort of like a web application that's grab the data and go. Does that make sense? So we don't have that feature in our database, in our website, but we could implement it using HTML5. So what do I mean by that? There are ways to have a local SQL database attached to your browser. And in fact, almost all browsers now come with a local SQL database. And that will allow you, let's say, to take lesson 6 for this week, put it into your browser, download it, and then if you already have it, I can write an application that says if it's in your local database, you don't need to go back to my database to get a new version. It's already there. So has anyone used applications like that? They're very rare right now at this point, but because that capability is just starting to become.
So it's like caching.
It's like caching a database locally in your browser. So does anyone use Evernote? Does anyone use that? Yeah, so that kind of does this. You know, you have a document. It's a little bit like Google Drive in a way also. But the point is, I believe, I don't think we're there yet this year, but in 2 years from now, we're going to be writing these applications very differently. So like my class application, you could have a local database with most of the data, and you only go to my data to sync it up. So you could be offline and read our website, theoretically. Or only need to go online if that website has changed. So kind of beyond this class and kind of beyond what's possible today, but distributed databases are very powerful. And if you think about it, that really is what GitHub is. It's a distributed database. It's a specialized database that only deals with what? It only has one table, a table that deals with a document, and a bunch of rows, and there's probably a row for every line in that document. And if two people change the same line, it knows that. There's a conflict, right? But the point about the distributed is you've got a local copy, and with GitHub, you have the ability to push up a server-based copy. And if you're working with multiple people, when you pull the repository down and start working on it, it only gives you the changes from the last time you committed. Does that make sense? So it's a synchronized, GitHub is very much a distributed database. And that's why we can't use it today the right way through the browser mode only, right? Because not all browsers have databases built inside of them. You need to install the software to have a local database to build your repository to sync back up with the server. So we're getting a little bit beyond the distributed databases. But at this point, the thing to remember is databases store data. Databases speak the language of SQL. The only way to interact with a relational database is through the SQL language. Even if you're using MySQL Workbench, you saw how that ultimately, all this tool is a bunch of buttons and WYSIWYGs to create SQL. Just like Dreamweaver is a $400 thing with a bunch of buttons for creating HTML. That's all it could do, really, right? And a database organizes data tabularly into rows and columns. And beyond a simple spreadsheet program, it allows you to relate those rows and columns to create a meaningful view of data. So I have one set. After you did apply, so I didn't do anything after I applied, other than I went back and looked at the results of what I did, which is I did edit table data, and that brings up the data in a tabular fashion. So you're looking at the data, not the structure. It's a big difference between alter table, which allows you to change the structure, the columns of the table, and edit data, which allows you to change the data within the structure, right? That's a kind of a fundamental concept. But that's what I did. Any other questions? Mine table disappeared. Well, you might need to open this up. But if you created it, it probably worked, unless you created it in a schema that you created, which I find they delete in a minute or two anyway. So do you mind if I delete this table? It's in your account. I just used it as an example. Okay, so can I still see this data? Let me try to refresh this. Yeah, it's gone because I deleted the table. Makes sense? You can't see stuff that ain't there. So, any other questions? Online. I think I answered them all. Is migrate like export? Migrate is migrate like export. Migrate is might be moving it from one type of database to another, from MySQL to Oracle or something like that. Export is taking the data out and storing it. So I think they're slightly different. We're not going to do either in this class. He wants to export his export DB to local. There's nothing. Is my so yeah. So if you go back to the splash screen, you could export by going into server administrator. So I could create a new server instance. Nope, I don't want to do that. Manage server instances. And I think if I yeah, I'm not really sure. So let me say this again. One, there's a class here in MySQL. My intent, this class is not to teach that. I have taught that class before. This is going to be a very limited subset. So I could spend a lot of time talking about, there are people who have PhDs in relational databases, right? That's not the purpose here. We're going to learn how to use your relational database to create a website. So you don't need to export. You don't need to migrate. You don't need to, there's not going to be any questions on the test about this side of MySQL Workbench. You don't need to be an expert in MySQL Workbench. You need to be able to install it and create a table. That's all you really need to do in MySQL Workbench. So some of these questions are great. And you know, there's all sorts of things you can do to export data, to migrate it into different things, but I could spend the whole semester on this. Talk to LaDon, who teaches the SQL class. It's a great class. I kind of created the outline. She's doing the class now, and you could take that class. It's taught in the spring. It's taught the same time as this class, which is kind of ironic. Oh, you taking the class? Oh, how was the class going? Do you know more about SQL now than we did just now? So you're more advanced than me.
Oh, yeah.
That's good. How's she doing? Good? Great, great. It's good to hear. Okay, so there's no more questions. I think if you click Manage, Import, Export. Yeah, so like I said, I don't have time to go through the administrative stuff, but exporting a database essentially means taking all the tables and creating scripts so that you could recreate them, and taking all the data within the tables and creating scripts so that you can reinsert them. Remember, the only way to talk to a database is through SQL. So how do you back up a database? It is essentially all the scripts you need to recreate it. Does that make sense? And how do you import a database? You run those scripts, and it'll create the tables that you already have. So when you do an import and export, when you export, all you're doing is creating a giant script that allows you to recreate the tables and insert the data that's in your tables. That's all I'm going to talk about in terms of export. You don't need to know it for this class. If you lose your tables, you can recreate them. We're not creating any fancy tables here. We're doing very minimal SQL. What you will learn, though, is how to tie a database to a web page and how to do that effectively. That's really what this class is about. you can learn a lot more about designing databases in the SQL class, and even that class. One semester isn't enough to learn everything you need to know about designing a good database. So I'll leave it at that. See you guys next Wednesday. Next Wednesday is the 6th, I believe. And then the week after that is the midterm, the 13th. And then the week after that is spring break. So we'll talk about that next week. Next week we'll kind of do, that's a good point. We are all over the place in this class. So we'll kind of do a review. Because while we're all over the place, all these things kind of relate. And we're going to tie them all together once we learn enough about all of them. But before the midterm, I will try to kind of paint a picture of how all this fits together.
So we're not banging our heads on the counter from the midterm. Okay.
Where do I start to learn this stuff? Yeah, you don't need to bang your heads against it. So, great. So I am going to stop the session. How do I stop the session? Session plan, applicant, stop sharing. Stop recording. Okay, good.